There are two methods for doing this question, so I'm going to talk through them both. Method 1. We are told that there's a straight line with a positive gradient, passes through 0, 2, and is tangent to this curve. Now I can write that down as y equals mx plus 2. Now because it is a tangent to this curve, that means it's just going to glance off of it in one place, and hence if I solve these two simultaneously, I will only expect to get one solution. So solve simultaneously with y equals x squared minus x plus 6. So it must be that mx plus 2, this point, is equal to x squared minus x plus 6, and therefore x squared minus x minus mx, which I could write as m plus 1x. That's the same thing because I'm minusing mx and I'm minusing x, plus 4 equals 0. So it must be that the discriminant is equal to 0 since there's a one root to this. I'm using the idea that if the discriminant was greater than 0, we'd get 2 points of intersection like this. If it was less than 0, we'd get no points of intersection. But because there's 1 point of intersection because it's a tangent, then the discriminant is equal to 0. And therefore, we can set the square of this, which is simply m plus 1 squared, minus 4ac equals 0. That means that m plus 1 squared is going to equal 16. Actually, I don't need to square this out. I can take the square root at this point. M plus 1 must equal plus or minus 4. So m is equal to, when it's positive 4, it's going to be 3. When it's minus 4, it's going to be minus 5. And we're going to reject that one because it said it has a positive gradient. Now, what was I actually asked for? The equation of the straight line. So it's going to be y equals 3x plus 2. Nice one. Method 2. In this method, we actually find dy by dx, which gives us 2x minus 1. So that's the gradient anywhere along this quadratic. So we need to be careful now. We can still actually use y equals mx plus 2 as a straight line, but when the tangent meets the curve, we can actually replace this m by 2x minus 1. So this is not the sort of the general equation of the straight line, it's just when it meets the curve. It's a little bit harder to understand, I think. But now we can actually set the two equal to one another because we have the equation for the quadratic and we have the equation for the tangent when it meets this quadratic. So write down 2x minus 1 times x plus 2 equals x squared minus x plus 6. Multiply out. Actually, these minus x's are going to cancel. I'm going to be left with x squared equals 4. So x is equal to plus or minus 2. And I can put that back in. So the tangent is going to be y equals, and then when I put 2 in, I'm going to get 3x plus 2. When I put minus 2 in, I'm going to get minus 5x plus 2. Which I will reject because it's not positive. So again, we get the same answer. I got to say, I think I prefer this first method. I think it's a bit more transparent. Both a bit challenging, to be fair, but I hope you're happy with at least one of them.